Nice to meet you. I'm Khadir Choktai and you're watching my YouTube channel School of Advanced Chemistry. I'm going to explain alcohol. Alcohol for O-level chemistry and IGCSE chemistry students. Alcohols. What are alcohols? And we are going to talk about its preparation, its properties, its nomenclature, and so on. Let's talk about it. Alcohols are the organic compounds having OH group attached to the simple carbons. Any organic compound that is having OH group attaching with a simple carbon is said to be alcohol. OH, if the OH group is present with carbon atom and any compound that is having a simple carbon and it is having OH group attached to it, it is said to be alcohol. The general formula of alcohol is CnH2n plus 2O or CnH2n plus 1OH. For example, if I'm going to put 1 over here, if I'm going to put n is equal to 1, then the formula will be equal to, the molecular formula will be equal to C1. And if 1 over here, similarly, it will be equal to H4O. So this is the molecular formula of one carbon alcohol. Same is the case if I am going to put 1 over here and 1 over here, then same the formula, the answer will also be CH4O. Same is the case if I'm going to put 2 over here, I mean if n is equal to 2, then its formula will be C2 and H6O. Or it can also be written as, if I'm going to put again 2 over here, then its formula can be written as C2H5OH. These both are one and the same thing. These both are having 2 carbons and 6 hydrogen, 1 oxygen, 1 oxygen. So this is the general formula of any alcohol that is having one OH group. Any alcohol that is having one OH group, so this is the basic general formula for that alcohol. Alcohol homologous series start from methanol. The first member is said to be methanol. The second member is said to be ethanol. Third member propanol, butanol, and so on. All have OH functional group, at least one OH functional group, and their name ends with the suffix OL. OL is the last part of the name of all alcohols. And the most important thing is they all are liquids. They are all volatile liquids at a room temperature. They all are liquids, methanol, ethanol, propanol, butanol. They all are liquid at the room temperature and their ending name is with OL. Any organic compound whose ending name is with OL, then it means it is having at least one alcoholic group. For example, cholesterol. Cholesterol, why there is OL over here? This OL is indicating that that is the indication of OH group. If there is one OH group, this cholesterol is basically having one OH group in it. That's why its name is said to be or known as cholesterol, ol for OH group. First member is said to be methanol and its displayed formula is this one, CH3OH. It is called methanol. And methanol. The complete nomenclature, I have made my lecture about the complete nomenclature. You can visit my previous lecture on YouTube. And here is the mechanism, general mechanism, how to give the name. I mean, I'm going to write meth for one carbon because it is having overall one carbon. There's no branch. And for OH group, I have attached this ol word for OH group. And ane is because is there any one carbon or there is carbon-carbon, all carbon-carbon single bond. The second member is having 2 carbon of famous alcohol that is used for the drinking purpose, that is said to be ethanol. This is the displayed formula. and its name is ethane ol. There is no need to write E, just AN. Ane, eth for 2 carbon, ane for carbon carbon single bond, and ol for OH group. Ethane ol. Third member is having 3 carbon atom, and one of the possible option with 3 carbon atom and 1 OH group is this one. This is said to be prop because it is having 3 carbon atom, ane because there are all carbon to carbon single bond, and ol. But this time you are going to show the position of OH group. If there are 3 or more than 3 carbon atom, then you will have to specify the position of functional group. So I'm going to write the functional group position that is equal to 1 over here, and it is called propane 1 ol. Propane 1 ol is the name of compound. The second possible structure, or the second possible alcohol with the 3 carbon atom and 1 OH group is this one. In this case, once again, you will have to mention the position of OH group, and this time you will have to mark numbering again. So let's suppose this is the carbon number 1, this is the carbon number 2, and this is the carbon number 3, and this 2 carbon is having OH group over here. So basically, generally, the position of OH group is also 2. So this numbering is for the OH group position to declare the position of OH group. You can mark the numbering from either side, either from the right hand side or from the left hand side, and so on. In this case, the OH position will remain same, that is equal to 2. So the name 3 carbon mean prop, all carbon carbon is single bond, ane dash 2 is the position of alcohol, and OH group mean name is ol. So propane 2 ol is the name of this compound. The third member, again, as I told you, it may have some branched or unbranched structures. The next members may have branched or unbranched structure. If you're exceeding from 3 carbon, I mean if you're having 4 carbon atoms in your chain, in your compound, or more than 4 carbon atom, then there may be the possibility of, or there you can say there must be the possibility of branched or unbranched compound. The fourth member, as I told you, it is having now 4 carbon atom. It is having 4 carbon atom, and this is the fourth member. One of the possible structure formula with the 4 carbon atom is this one, and it is having 4 carbon, 10 hydrogen, and 1 oxygen. Again, it is important to mark numbering from the end, which end is closer to the OH group. This time you will have to check the longest chain as well. This is the longest continuous chain of the carbon atom, and this carbon is said to be carbon number 1 because it is very much closer to the OH group. So the name is bute, because 4 carbon atoms are over here. 4 carbon atom names start from bute, carbon carbon single bond, ane dash 1 is the position of alcohol OH group, OH mean ol, butane 1 ol. Come toward the second option. If I'm having the same carbon chain, I mean again I am having the longest chain of 4 carbon atom, but this time I have changed the position of OH group over here. Now I'm going to mark numbering once again, and first of all I will select the longest chain. As you know, the longest chain is a similar one, 4 carbon atom. And if I'm going to start numbering from the right hand side, this is the right hand side, this is the carbon number 1, this is carbon number 2, this is carbon number 3, and this is carbon number 4. If I'm going to mark numbering from the left hand side, then this is the carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So this time the OH group is going to have different numbers. From right to left, it is going to have number 2, and from left to right, its position is equal to 3. But the lowest position is preferred. The lowest position, the lowest number is always preferred. So what is its name? 4 carbons are lying in the chain. There is no branch. So its name will start from bute, and ane for single bond, carbon-carbon single bond, dash 2 is the position of OH group, and OH name is ol. So butane 2-ol is the name of this compound. And these both structure are said to be unbranched structure. These are said to be unbranched structures, and so on. Now the next thing is, if I'm going to make the branch with the 4 carbon atom, and here it is, and 3 carbons are lying in the same chain, and 1 carbon is on the as a branch, is acting as a branch, and so on. So CH3, 3 CH3 are over here. Let's suppose I'm going to add OH group over here. So this structure is said to be branched structure. It is said to be branched structure. Why it is said to be branched structure? Because if I'm going to select the longest chain, then there is the longest chain that is having 3 carbon atom. Not all the carbon atom can be in one chain, in one continuous longest chain. So this is said to be a branch. So this is said to be branch structure. Again, I will have to numbers. I will have to mark the number. So I'm starting from right to left. 1, 2, and 3. I mean, I'm marking the number on the longest chain. In this case, 2 position is for OH group, and same the 2 position is for this branch that is said to be methyl. If I'm going to reverse numbering, 1 carbon is 2 is 3, so numbering are same in both cases. So how to write the name? First of all, I will write the name of branch. Branch is having 1 carbon atom. 1 carbon branch is said to be or known as methyl. And what is its position? Position is 2. 2-methyl. So whenever we write the branch, we write the position dash then its name. 2-methyl, then we will have to write the number of this longest chain that is having 3 carbon atom. Mean you will write prop, carbon-carbon single bond, you will write ane dash, and there is the OH group at 2 position, so I will write 2-ol. So 2-methyl propane 2-ol is the name of this compound. I'm going to make another molecule that is also having the branch structure, but this time I'm going to change the position of OH group. I'm going to change the position of OH group. So once again, the longest chain is equal to 3 carbon atom. This is the longest chain of the carbon atom, and this is the OH group, and this is the branch. Now we will have to mark the numbering, but the numbering is preferred with respect to functional group. So this carbon is very much closer to the functional group, so this carbon will always be carbon number 1. Carbon number 1. So it is carbon number 2 is carbon number 3. Now this time the branch is having 2 position again like the previous one. So what will its name? The position of branch 2, and 2-methyl is the name of branch. We write YL at the end of name. Met mean 1 carbon, and if it's branch, if it is having 1 less hydrogen as compared to its alkane, so its name will be YL, methyl. Then how many carbons are there? 3 carbons, so there is no dash. Simply we will continue to write the name prop, and carbon-carbon single bonds are over here. So ane, and there is no need to write E. We will not write E dash, and ol, that is having 1 position, 1-ol. So 2-methyl propane 1-ol is the name of this compound. So these all are the alcohol. Those are having 4 carbon atoms and 1 OH group. So these all are also said to be isomers. These all are said to be isomers. Compounds having same molecular formula. They all are having same molecular formula, but different structured formula or different names. They are having different name. These four compounds are having different names, but these four compounds are having same molecular formula, so they are also said to be the isomers. Now come towards the preparation of ethanol. There are basically two methods to prepare ethanol, specifically ethanol. Number one is said to be fermentation, and the second one is said to be from alkene. The fermentation is said to be known as from renewable sources. The fermentation process, this process is said to be having the renewable source. How and why it is said to be the fermentation is going to have renewable sources? The basic reason is the ethanol is produced from fermentation from glucose. We can reproduce glucose every year, and that's why this process is said to be renewable source process. And you can find, glucose is obtained from sugarcane, grapes, fruits, and so on. So basically, there are the different sources of glucose, and then if we are having glucose, then glucose can be changed into ethanol by fermentation. So the process of fermentation is having renewable sources or renewable ingredients. Sugar can be obtained from sugarcane, from apples, from grapes, from different fruits, and so on. So now come towards the fermentation. The process of the fermentation and what are the conditions of fermentation. First of all, basically, glucose and the water solution is mixed over here. We are having the solution of sugar solution, basically solution of glucose over here, and we add yeast into it. And it is stand for some time, some days even, you can say. The next thing is, the yeast is the microorganism which converts glucose into ethanol. This yeast basically convert glucose into ethanol, glucose solution into the ethanol. Temperature of the mixture is kept almost less than 40 degrees Celsius, because more than 40 degrees Celsius, yeast may die. Yeast will not work properly if you are going to increase the temperature from the 40 degree. So the basic temperature that is usually kept, that is 20 to 40 degree Celsius. Ethanol formed is distilled off as soon as possible. The ethanol that is being formed in the reaction mixture is basically distilled off when it exceeds to the percentage level of 15. So in the container, ethanol must not be more than 15%. It must be less than 15%, and it is immediately distilled off then. pH of the reaction mixture is kept 7. 7 means there is no acidic compound, there is no alkaline compound in the solution. So pH is maintained 7 in the reaction mixture. Carbon dioxide that is being formed in this process is allowed to escape. CO2 is allowed to escape from the reaction mixture, and no oxygen is allowed to enter into the mixture. Oxygen is not allowed to enter into the mixture. CO2 is immediately allowed to escape the mixture. Now, what is the equation of fermentation? This is the formula of glucose, C6H12O6, aqueous solution of glucose. In the presence of yeast, after some time, yeast convert this glucose into alcohol. There is the 2 mole of ethanol, C2H5OH aqueous, and 2 mole of carbon dioxide gas is formed. Plus, in addition to that, energy is also produced. Basically, the large molecule of glucose is changed into small molecule. One small molecule is ethanol, and other one small molecule is carbon dioxide. So this is said to be the reaction of fermentation. Once again, in fermentation, the aqueous glucose is converted into 2 mole of ethanol aqueous and 2 mole of carbon dioxide gas. Moreover, energy is also released or formed in this process. The next process is from non-renewable source, that is said to be ethene. Basically, ethene is obtained from crude oil. Ethene is obtained, or the source of ethene is from crude oil, and crude oil is said to be the non-renewable source, and it is depleting with the passage of time. Ethanol is produced by the catalytic addition of steam into ethene. Steam into ethene, and ethene is extracted from crude oil or the petroleum, so that is why it is a non-renewable source, and it is depleting with the passage of time. Condition for this reaction, there are basically three conditions. Catalyst is phosphoric acid, and pressure is 70 atm, and temperature is kept 330 degrees Celsius. So phosphoric acid is used. This is said to be H3PO4, phosphoric acid. 70 atm pressure is used during the course of that chemical reaction, and the whole reaction mixture is heated more than 300 degrees Celsius. So these are the basic three major conditions to obtain the maximum yield and to make at the faster speed. Once again, ethene is a non-renewable source, as ethene is being formed from petroleum, from crude oil mixture, and we add steam into the ethene, and the new product, the new compound is said to be alcohol. From non-renewable source, how to write the equations of these, how to write the equation from ethene, how to make ethanol from ethene. So let's see over here, if I'm going to have ethene, this is the ethene. If I'm going to add water, that is called HOH, water. You can write water like that. So our H3PO4 as a catalyst, and 70 atm pressure, and 3 or more than 300 degrees Celsius temperature. Then there is a breakage of one of the double bond, and here is a breakage of one of OH bond, and we are going to have this one new compound. One carbon will have this hydrogen, and one carbon will be having this one OH group. So OH group, and the new compound is said to be ethanol. Is said to be ethanol. So this is the laboratory method, you can say, and this is said to be the method which is which is having non-renewable source, that is alkene, ethene. Now come towards the chemical properties. What are the basic chemical properties of alkene? Number one, first of all, that is said to be oxidation. Oxidation means addition of oxygen or removal of hydrogen. These are the two basic definitions. Those are used in organic chemistry. In organic chemistry, addition of oxygen is called oxidation. Minus hydrogen means removal of hydrogen is also said to be oxidation. And here are a few famous oxidizing agents. Number one, KMnO4. That is purple in color. KMnO4 is a strong oxidizing agent that is basically used with acid, and it is said to be acidified KMnO4. Same is the case acidified potassium dichromate. Acidified potassium dichromate. And simple air or oxygen, sometimes that is also be used for the oxidation or oxidizing agent. So oxidation is addition of oxygen and removal of hydrogen. Let's see over here. In case of oxidation, first of all, I'm going to write one carbon alcohol. How to make its oxidation? Number one, I'm going to add bracket and oxygen. This is called atomic oxygen, and this oxygen is atomic oxygen, and that is given by the oxidizing agent. This is given by the oxidizing agent. Goes to. So what is the basic and first step? The first step is removal of two hydrogen. One hydrogen will be from this oxygen, and one hydrogen will be from this carbon. So the carbon which is directly bonded with the OH group, one hydrogen will be lost from that carbon, and one hydrogen will be lost from OH group. So the loss of two hydrogen is said to be oxidation. In first step, there is a loss of two hydrogens, and it is called, as you know, oxidation. Then what will happen to the rest of the molecule? It will make, then there is, you can say, making carbon oxygen double bond in next step, you can say. And the third and the further and the final step, if the still you are having one hydrogen with this carbon, if this carbon is again left with one hydrogen, then this there is addition of, or there is introduction of oxygen with one hydrogen. Any one of hydrogen may get one oxygen. So in first step, there is the removal of hydrogen, removal of two hydrogens. In second step, there is introduction of oxygen. So finally we are going to have this compound that is said to be acid, an acid in this case, and it is said to be methanoic acid. So first of all, it will change into this compound. In first step, it will change into this compound. Then again, there is addition of oxygen with any of these hydrogen atom. And finally, we are going to have an acid, this compound. So that is said to be the final answer. Finally, this methanol can be changed into methanoic acid. Methanoic acid, methanoic acid. So one carbon alcohol changes into one carbon acid. Or you can say, if you want to synthesize one carbon acid, then you will have to start from one carbon alcohol. Same is the case if you are going to start from two carbon alcohol. Two carbon alcohol will make two carbon acid. For example, I'm having two carbon alcohol. That is once again a famous alcohol that is said to be ethanol. In case of ethanol, all changes will be on this carbon atom. One hydrogen will be lost over here, one will be lost, let's suppose, over here. Over here, this carbon oxygen will become double bond, and if still this carbon is having hydrogen, then it will be changed into OH group. H will be changed into OH group. So finally, you can see that I have made its full oxidized form. I have made its full oxidized form, and this is called 2-carbon acid, and its name is ethanoic acid or vinegar. Ethanoic acid. Ethanoic acid. So I mean, if you're having one carbon alcohol, one carbon in alcohol, then you will make one carbon acid. If you're having two carbon in alcohol, you will make two carbon acid. If you're going to have three carbon in alcohol, you will make three carbon acid, and so on. So this is the basic mechanism how to make oxidation. Now the last one is how to write the balanced chemical equation for any oxidation process. Once again, I'm going to start from the simple alcohol, the first one. It was CH3OH plus bracket, small square bracket, oxygen, and goes to, finally we have made this compound that is having one carbon, that is having two hydrogen and two oxygen, plus we will write H2O. So to balance this chemical equation, we will mark 2 over here, we will write H2O over here. So this is the complete balance equation. So whenever alcohol is allowed to react with oxygen, this oxygen came from the oxidizing agent from K2Cr2O7, that is acidified K2Cr2O7. There must be an acidic solution, there must be the heat. So these are called conditions. Acidified KMnO4, H positive ion mean acidified KMnO4, and there must be heat as well. So under such condition, you are going to have the oxidized product, and there will be the formation of water molecule. In addition to that, an acidic group. So in form of equation, you can express oxidation like that. Now come toward this example in which we are having the OH group over here and 3 carbons are over here. So once again, the first step is to remove 2 hydrogens, one from OH group and other one from the carbon atom. And then you will make carbon oxygen double bond. Yes, you can do it over here, but there is no next step because this carbon is no more having no more hydrogen atom with it. So this is the last product. Moreover, its name is not included in your syllabus, but this is the final oxidized form of alcohol. And for the sake of balancing, you will write 1. There is no need to write any other number. Same is the case if I'm going to write another alcohol, that is a 4 carbon alcohol, and let's suppose I'm having this one alcohol and it is said to be 2-methyl butane 2-ol. 2-methyl butane 2-ol. So once again, if I'm going to oxidize this alcohol under similar condition with acidified KMnO4 with heat. So first of all, I will have to remove 2 hydrogen, 1 hydrogen from here and the second hydrogen from where? No, we cannot remove 2 hydrogen. We cannot remove 2 hydrogen from this molecule. This carbon is having no hydrogen, so this molecule cannot be oxidized. It can be oxidized. So simply follow these rules of oxidation. First, we will remove 2 hydrogen, that is said to be oxidation. In next step, if there is possible, then we will add oxygen. But the first step is once again, remove 2 hydrogen, make carbon oxygen double bond. And then if this carbon is yet having hydrogen, then you will make this hydrogen, you will change this hydrogen into OH group. But if there is no hydrogen, I'll leave it like that. So this is the basic mechanism, basic tips and tricks how to write the product of oxidation of alcohol. The next thing is dehydration. You can dehydrate alcohols, different alcohols, and the conditions are basically concentrated H2SO4 and heat up to 170 degree or above. So concentrated sulfuric acid plus 170 degree heat is required. Once again, I'm going to write 2 carbon alcohol, for example. At least 2 carbon alcohol can be dehydrated, but 1 carbon alcohol cannot be dehydrated. So what is the dehydration basically? 1 carbon alcohol cannot be dehydrated. What is the reason behind it? The reason is in dehydration, 1 OH group is lost, 1 carbon loses OH group, and its neighboring carbon, its immediate neighbors neighboring carbon will lose any of 1 H. So H and OH is called hydration, or it's called water. D mean removal, hydra mean water, hydration mean the process of removal of water, dehydration process of removal of water. So in this case, this 1 carbon is having OH group, fine, but the loss of hydrogen will be from the next carbon. As you can see that there is no other carbon to lose hydrogen, so it cannot be dehydrated. But this alcohol can be dehydrated, and finally we will make 2 things. Number 1, carbon-carbon double bond compound. This time this is called ethene. Plus every time we will make H2O, as we are supposed to remove water, and it is said to be dehydration reaction. So dehydration reaction is the reciprocal, is the reverse reaction of addition of steam or addition of water into alkene. And once again, you will use sulfuric acid, concentrated sulfuric acid, and at least 170-degree heat to remove water molecule from alcohol. So alcohols can be dehydrated, but one carbon alcohol cannot be dehydrated. The next thing is esterification. Alcohols on reaction with carboxylic acid. Alcohols and carboxylic acid meets together to make a sweet smelling liquid that is called ester in the presence of concentrated sulfuric acid and heat. So the process of formation of ester is called esterification, or sometimes this reaction is also said to be condensation reaction. Condensation reaction. So condensation reaction or esterification, that is also the property of alcohol and organic acid. For example, I am going to write it over here. For example, I am going to write one carbon acid that is said to be methanoic acid, and I'm also writing one carbon alcohol that is said to be methanol. So how the condensation occur in this case? Basically, this acid is not behaving as an acid, and it is going to lose OH group. So this acid, its name is acid, but it's not going to behave as an acid because it is losing OH group, and this acid is losing H group. So H from alcohol and OH from acid, they are going to make water, and this process is called condensation. When two different molecule, or to say molecule, when they are getting together, meeting together to make H2O, then especially a small molecule, HCl, a small molecule, then this is said to be condensation process. And as a result of this process, we are going to have the remaining part will be joined to each other's. So O and CH3 over here. And the name of this compound is methyl methanoate. Methyl methanoate. Methyl methanoate is the name of this compound, and this is called esterification, this is called condensation, and so on. Come towards another second example. If I'm going to use two carbon acid and let's suppose two carbon alcohol. Once again, this acid is not behaving as an acid in this reaction because it is losing OH group, and this alcohol is losing H group, and we are going to have a new compound, a sweet smelling liquid that is called ester. And what is the name of this ester? This ester is said to be ethyl ethanoate. This is the new compound that is called ester, and it is said to be ethyl ethanoate. Ethyl ethanoate is the name of this compound. So this is also the property of alcohol, that they can react with carboxylic acid, they can react with another compound that is said to be acyl chloride, and they can give ester, sweet smelling liquid esters. Now the reaction with metal, these alcohol can react with metal. For example, I am going to write one carbon alcohol for the sake of simplicity. And for example, if you are using the metal, those are more reactive than the copper in the reactivity series. For example, I am going to write magnesium over here. So they can react. This OH group can react with the metal. Yes, it is true. This metal is more active than hydrogen, so it will replace this hydrogen from this alcohol. The remaining part of alcohol will be over here, that is having one negative charge over here, and overall there will be the positive charge or the positive ion of metal, and the metal, magnesium metal, is making two positive charge, and here is a one negative charge. So how to make the formula? Positive and negative will be cancel out. Two will be over here, one will be over here. So there is a formation of salt, CH3O twice Mg. This is a salt plus hydrogen H2. Hydrogen gas will be formed. And so for the sake of balancing, I will have to put 2 over here. So ethanol can react with the metals. I mean with sodium metal, with potassium metal, with calcium metal, with magnesium, with aluminium, if it is, not having the coating of Al2O3, and with the zinc metal, with the iron, and so on. They can react with these sort of metals, and they can make hydrogen gas every time, and a salt is formed over here with respect to that metal. Come towards the properties and uses of alcohol. Alcohols are liquid at room temperature and they are highly soluble in water. Commercially, ethanol is used as a solvent, and the tincture of iodine after aftershave lotions, in tincture of iodine, Ethanol is used as an antiseptic agent in form of spirit. Ethanol is used in alcoholic beverages like wine, beers. Ethanol is used as a fuel, rocket and racing car fuel. Ethanol is used in cosmetics, in the formation of cosmetics. That's all about this alcohol, this lecture. Thank you very much. Please subscribe my channel, hit the bell icon, and share it with your friend. Thank you. Thank you very much. Have a nice day.